Hello everybody, welcome back. Today we're looking at example 4 from 6.1. This will be our last video for section 6.1. It says graph of the point xy such that 3x plus 4y greater than or equal to negative 12, x is on the rails, y is on the rails. So this is a good one to show graphing the x and y intercepts because 3 and 4 are both factors of 12. So therefore this is going to give us a nice x-intercept and a nice y-intercept. So we're going to use that method from last year. Okay? So the first thing we're going to do is we're going to find the y-intercept. Okay? That's our first call here. Find the y-intercept. Okay? So how do we find the y-intercept? You guys hopefully remember from last year, and if you don't, that's fine. We let x equals 0, right? So if you let x equal 0, we take the original equation, or inequality, I said it again, I do apologize. So we take the original, okay, and we let x equal 0. Okay, so we take the equation, everywhere we see x, we put in 0, okay. I'm going to solve that with 3 times 0 is obviously 0, so that's gone, leaves with 4y. Divide both sides by 4. Now we divide both sides by 4. Again, you don't have to show this step, but you can divide by 4. Divide by 4. Right? And you're left with y equal to negative. And again, this, I guess I should have, you can change this inequality to an equals, just for the purpose of x and y intercepts. We're not getting rid of the inequality altogether. This just shows you when you're solving for it, again, it doesn't make a difference. So now we have the point 0 and negative 3. Okay? Oh, 0 and negative 3. So that's your y-intercept. Now we do the same thing, find the x-intercept. Find the x-intercept. So obviously we do the opposite. We let y equal 0. I'm just stealing that. Let y equal 0. Okay? So we take our inequality and just change it to an equation for now. Everywhere we see y, we put in 0. Right? That's gone. If we multiply 4 by 0, it's gone. And we divide by 3. Divide by 3. And that will give us x equal to negative 4. Okay? So that tells us that our coordinate is negative 4 and 0. Okay? So we have the x-intercept and the y-intercept. That gives us 2 points on our graph, and then we can graph the inequality. It's as simple as that. Okay? So I'm going to show that on the Desmos program. Right? So this is a method that we did last year when we graphed a linear equation that wasn't in the form of y equals mx plus p. Again, this was a great example because it gave us nice integers, values, right? Where there was no decimals or anything. Okay, so it really lended itself well to this question. So to graph this in Desmos, we just get the Desmos program up. So we're going to graph those 2 points, 0 and negative 3. Label that. And then we graph negative 4 and 0. Oh. Label that point. So we have our 2 coordinates, right? And then we're going to graph a line through. And again, this one's going to be a solid line. And the reason it's going to be solid is because there's the inequality was greater than, right? Okay. So we'll graph that line. Okay. So the line, 12. So we're heading right through. I'll put it in black. Okay. We draw a line through. And remember now we do our inequality. Okay. So we do our test point. Let's test 0, 0. Inequality. So if we test 0, 0, let's go back. We'll do a test point. Okay. Because our equation is not in y equals mx plus b, you may want to do a test point here. All right. So remember, test point. If you do recall, test point we usually pick is 0, 0 is a good one. Okay. So we take the original inequality. Take the original inequality. Add 0. Add 0 in for both. So 0 plus 0 is 0. 0 is greater or equal to negative 12, so this is true. So I'm going to steal that line to the last. So since this is true, we shade the arrow with, right? That is a true statement. Okay? So since this is true, we shade the area with the test point. So we'll go to our Desmos program. Desmos here. Okay, get rid of the we need that. There we go. So there's our inequality. Now we're going to graph the inequality on the correct side. So put a line, shade the region. And so we said the 0, 0 shaded, so we want to shade above, right? So we shade above. I don't like the black color just because it's really dark, so I'll put a lighter color here, like a red. Okay, and you put any color you want. Just shade it with your pencil, right? And that's it. That's all you need to do. And there's your graph. Okay? So we're going to take a picture of that for our notes. And when you graph that equation showing all your supporting work, that's it. You're done. Okay? So there's your graph. And again, you do that graph by hand. No big deal at all. All right. That graph where we need to go. That's perfect. Okay? So remember, it was true. 0, 0 was our test point right here. So we shade the region with 0, 0. Remember, we hadn't had a time where it was false yet, but if it was false, you would shade the other side. Okay? Yeah, and that's it. And again, you can think of the y going to be on this side. It'd be greater than or equal to it, so it's above. If that works in your head, it's up to you, right? Okay? The only trick to that would be, remember, when you multiply or divide by a negative number, when you're rearranging, that would change the inequality, so you have to be careful there. So basically, your coefficient can't be negative in front of the y if it was in this form. But anyway, there's no guessing with the test. Using a test point, it's bulletproof, and you're good to go. Okay? So this is the homework questions. You're going to do those. There'll be no videos for the homework questions. All the resources are located on the Google Classroom. The textbook, the solutions to the textbook, it's all there to support you in your work. And of course, you can collaborate with your classmates and of course ask me questions. So thanks everybody for watching. That is the first 3 videos for 6 Decimal 1, and we'll start 6 Decimal 2 in the next video. Thanks again.